Everybody, I hope that you're doing well. Ready to talk about wetlands some more. And thought I'd share a little bit about what I've been up to in the last week or so when I've been able to get outside, which has been challenging lately given the weather that we've had. So we built a raised bed out in front of the house, which is kind of neat. My son is actually not trying to destroy it there; he's just posing, trying to grow a little more food here. It's a view of our backyard. It's like a lot of Asheville homes, it's pretty steeply sloped. So we put some raised beds on this hillside, and I've got a lot of work to do. You can't really see it, but this raised bed is starting to come apart a little bit. So I need to fix some of the boards and secure it, and so I've got lots of stuff to do with my free time if I get much. This is a place where we've done this hugel culture, putting logs in onto the along the hill, and it's gotten leveled pretty good there by now. We've kind of made a nice little flat space there. It's been probably 5 to 7 years since we've had it there, so growing some stuff there. Then we got some raised beds going along the side of the house there too. I don't know if you can see it, but these are starting to come apart too. So I've got to do some work there too. So a little bit of garden restoration, if you will. All right, so we've talked a little bit about wetlands, why they're important, how they've been degraded. So now we're going to talk about how we restore them. So the first thing is, before we even start to restore them, we need to think about a few things. Um, you know, as we talked about with stream restoration, we want to kind of work on a watershed approach. The best sites to restore are those that are going to be in bad shape in a generally good watershed. And it's a good idea to think first of all about, is this area even a wetland? Because if we're trying to restore it to a wetland, it might look very different now. So you can look at how it drains after a high rainfall event. You look at a topographical map, kind of see how the area lies, and you want to just take a couple practical steps and make sure that making the land wetter, which is basically what is going to be required to restore a wetland, is not going to negatively affect infrastructure, any roads, railroad lines, any buried power lines, that kind of thing. It's also important to see what the potential is for the community to naturally regenerate. And a good way to do that is to dig the soil out to about 30 centimeters or so, and then grow these out. Grow these out indoors and see what shows up, what native plants and invasive plants will show up. And so this will tell you whether you need to think about bringing in some seed for native plants, or if the seed bed is going to take care of it. Now, wetlands, again, like streams, are covered under the Clean Water Act, right? So that's the idea of what's called a jurisdictional wetland. So to do some of this work, obviously if the state's doing it, they'll have the permits and stuff in order. But even if you're doing this, especially if you're doing this on your own land, you need a permit if it's a jurisdictional wetland, and so you have to check on that. And then, really water is what drives these systems, so you have to be sure that the water that's entering the wetland is in good shape. And so, we're going to talk a little bit about how we do that to look for some of these potential issues. So to figure out if it used to be a wetland, there's a couple things to do. And if it's not a wetland now, you can't rely on saturation or hydrophytes, because if it's not wet, our hydrophytes won't be growing there, and of course the water won't be the area won't be saturated. So you can either rely on historical records, or you can dig and see if there are indicators of previous hydric soil conditions. All right, so in the picture here we've got some dark colored soil to the right, underneath some soil that hasn't ever been saturated. So we can look for that signature of hydric soil that tells you that not too long ago this area did used to be a wetland. So again, that restoration site at Mud Creek, I'll be referring back to that a couple times. And this is an interesting case because this place was used for agriculture, and so what was actually done was in addition to using drainage tiles to take the water out and kind of drop the water table, soil was brought in from upland areas to fill in low-lying areas and make it more amenable to agriculture. So the hydric soil itself was underneath all the soil that had been brought in. But when you look long enough, sure enough, there was hydric soil below, which indicates that this was a wetland and that's the natural state of this area. One thing I might mention is you can see that stream channel up above the restoration plan, and that's most definitely channelized, and so that's how the water would be gotten off of this area quickly. All right, so as far as restoring wetlands go, there's really 3 steps, and you may not need all 3 depending on the condition of your area. But the first and really the key is to reestablish hydrology and then maintain a natural hydrological pattern. Then you're going to want to think about contaminant inflow and how to deal with that. And the final piece, once you've got that under control, is seeing what the status of the native biota is, if you're going to have to work to reestablish that, or if it can come back on its own. All right, so what do we mean by hydrology anyway? Some of you might have taken a course in hydrology. So it's all about the movement and distribution of water. And so, if we're considering a wetland, certainly the volume of water is going to be important, right? Is the soil saturated or not? Direction of flow is going to be important. How does it move across the land? And then the timing as well, right? How often does it flood? How much time is the soil saturated? And so the goal is to try and reestablish all of these factors: the volume of water, which way it's moving, and then also how much you have at different times of the year. So since we've worked to get water off of these lands for so long, then generally what's needed is to find ways to get water back onto these sites. So this is a section of the Kissimmee River and wetland in Florida, and you see that that straight channel there that's been filled in the 60s. This massive wetland was essentially engineered to ameliorate flooding issues, but the problem was that in the process of doing that, they really damaged the wetland. So this restoration process went through and filled in that channelized section with the material they had dredged to recreate a natural-looking channel there on the right. This is a pretty dramatic case. This is what it looked like, moving a lot of soil, all that heavy machinery. Right? So literally taking the sediment that was dredged to create the new channel, and then pushing it into this previously channelized area to keep the water on the land longer, essentially. Now, in saltwater areas, it's all about allowing the salt water back into these marshes. And so what you generally see is that once you find ways to allow that salt water back into the marshes, then these native plants will come up again, like common reed, for instance. And so as long as you have a seed bank and you let the water do its thing naturally again, you're often in pretty good shape. However, simply reconnecting the hydrology is not going to be enough for sites like Mud Creek, where there was agriculture going on, right? Because first of all, you have soil that's been brought in from upland areas, and so that's not going to contain seeds. Second of all, that are wetland plants. Second of all, with all the ag that's been going on there for so long, it's very unlikely you're going to have any kind of a viable seed bank. So this is a picture that was taken in some high water several years ago. And so the site does flood now from time to time, but it still is not turning into anything that looks like a wetland at all. So you have to go through, and if there are any drainage tile systems, you have to destroy them. And you might have guessed by now that this kind of restoration often requires a lot of heavy machinery. And so that heavy machinery moving over these sites is often enough to break up those tiles, right? Those tiles, those pipes that are underground, and so those will be broken up just in the process generally of having machinery moving over them. But particularly if the hydrology has been severely altered, what's likely to happen is that you'll have sediment collecting in places where it shouldn't, if there's water moving in it, or it might have been dug out or had soil brought in to fill the wetland, like was the case with the Mud Creek site. So if that's the case, you may have to take an even more active approach and dredge to create topography that'll allow the water to move across that wetland again. It might be enough just to allow water to move again, but depending on the elevation, you may need to dredge things to create some level topography. So in this schematic of the Mud Creek site, what you notice is that there are several areas that they're going to essentially punch holes through that riparian zone to reconnect this land to the French Broad River. So the sort of pink stippled sections there are mountain bog habitat, and so those are connected areas that are going to be dug down low enough that they're going to be pretty close to level with the French Broad River when the water rises. So it's going to connect in that way. And you can see there's a little bit of deeper habitat that's going to be available as well. And then those yellow areas are also sections that are going to be dug through the riparian zone to connect the land to the river. And so those will fill up at high water. A couple other things to note is that there's actually a campsite that's going to be built here for the French Broad River paddle trail. That's that light blue cross-hatched area there right on Mud Creek. So that's kind of a bonus. And there's going to be a walking path on here as well. So they're trying to balance a little bit of recreation use of this area too. But you might notice the yellow there says muskie habitat. So the muskie is a fish that is native to the French Broad River that had all but disappeared, and so they're stocking it now, and it occurs in the very southernmost edge of its range in the French Broad River. It's interesting, though, of course, since the French Broad River flows north, that when you move further to the south, you actually come to cooler waters because you're getting toward the headwaters. So the French Broad River is a little bit unusual in that flowing to the north, just because of that, to the south, you're actually getting cooler waters as you get towards higher elevation. It's kind of a strange system. But the muskies don't naturally breed at all in the French Broad, and they think that the way they used to naturally breed was by accessing these wetlands during the flood. So they're going to punch these holes through the riparian zone and create these flooded areas where the muskies hopefully will be able to come and breed there. And if you've never seen a muskie, this is what they look like. They're big top predators. They're stocked by the state for game fishing, sport fishing. But you could argue that they're a keystone species in the French Broad River. So it'll be really interesting to see if they're able to breed in this wetland once it's created. The state has some research plans in place to monitor that. Okay, so you're working on reestablishing or managing ecology. The next thing to think about is contaminants. So, one thing that we got really good at in this country was reducing point sources of pollution through the 70s and 80s. The Clean Water Act got really good through some grant programs and other things at eliminating point source pollutants. So if there are any kind of sources like factories, anything that's bringing high levels of contaminants near the wetland, you're going to have to stop that. And in some cases, you may need to remove contaminated sediment. If those areas have been getting polluted for quite a while, that sediment may need to be taken out before you can go any further with a restoration plan. But one thing to keep in mind is that healthy wetlands are really good at removing certain pollutants. I think I mentioned, sediment is the biggest water pollution problem we have in the U.S. But as it says in the schematic here, right, wetland plants are really good at taking out sediment because it binds to their roots as it floats by them in the water. So if it's sediment or on the right nutrient pollution, wetlands are really good at taking that up. So we might not have to worry about that a lot if those are the only pollutants that we're dealing with. But unfortunately, if we're in agricultural areas, things like pesticides, herbicides, things like that might still be an issue. So we have to think about that. So in agriculture areas, that can be a problem. For example, in the Mills River watershed, there is land that's been used for farming for a long time. And back in the day, they actually used heavy metals as insecticides. And after that, it was DDT. So this stuff is in the soil, and so when it runs off after heavy rain and it really gets down into that soil and starts to wash off, then that can get into our aquatic ecosystem. So, but if it's just sediment and some nutrients, often healthy wetlands can take that out. Again, these are the kidneys of our aquatic ecosystems, right? They're able to take all that pollution out if given the chance and the right pollutant. So then the final piece is the native biota. So as far as getting the native species back in there, the amount of management required depends on a couple things. I might ask you at this point what those are. But the first piece is the natural source, right? So for instance, if you have a good seed bank, you might be okay, right? All you have to do is reconnect the hydrology, make sure you don't have contaminants coming in there, and then those native plants will come back up. And so that's more of a passive approach, of course. The other piece is the risk of invasive species. So what was mentioned earlier about taking the top 30 centimeters of soil and growing it out in a greenhouse, that will let you know just what your seed bank is like. And so if there are lots of invasive species there in the seed bank, then that may require some active removal, especially early on in succession, remember, because sometimes those invasive species, once they get established, are really hard to get rid of, and they don't allow native species to come in. So if there's a risk of invasive species, we may need to actively remove them, at least kind of early on in the process. Just to show you two examples of the spectrum. So at the Kissimmee River site, there was not a lot of development that went on here, not a lot of agricultural use. So there were a lot of native wetland plants that were still there, and there weren't a whole lot of invasives. So this is a nice story where once they found a way to keep that water on the land longer, it just created habitat that allowed these native plants to come back in. Again, contrasting that with the Mud Creek site and really any agricultural site, right? In this particular case, so the stage they're in right now, they're going to be they're contouring the site, but once they're done, they're going to have to come in and plant some native species, and once they obtained the site, once the state and their partners obtained the site, even before they started restoring it with the heavy machinery, they were going in there regularly and removing invasive species just to try and minimize the spread to give those native species a chance to get started. All right, so let's take a look at what this process looks like for different kinds of wetlands. Here we mentioned wetlands are like forests, right? There's all different kinds. Early successional, late successional, right? Saltwater, freshwater, different climates. So we're going to talk about three kinds. One is the coastal estuarine wetlands. The second are stream and river wetlands like we would see around here. And the third, large freshwater wetlands with poor drainage. So really large, low-lying elevational areas like we have in some coastal areas in the southeast, certainly down in Florida. All right, so these coastal estuarine wetlands along the ocean, the challenges that they're dealing with, first of all, is, for the longest time we thought that building walls was a good way to help out against storms, and so building these dikes, these are walls against the ocean. Well, that kept salt water from coming into these habitats. So many of them have dikes that have been put in, or they've been filled or ditched to help with mosquito control or other purposes. So the goal in a lot of these places is to let the ocean back in. So breach those dikes, restore vegetation, and then depending on what kind of filling has been going on, as we talked before, we may have to come in and fill in those canals and things that have been built to take the water off. It just depends on the topography. So here's an example of what it would look like to try and keep the water from going out. This is an aerial photo of the Everglades, this massive wetlands in Florida. And so you can see just in the center of your picture there's actually a big water regulation gate. And so they've installed dozens of these water regulation gates that where they can determine how much water moves in and out and kind of balance it to keep that real slow flow of water, which are how the Everglades have naturally been. On the other side, sometimes you have to let the water in. So this is restoration on Nisqually Delta on the west coast, where they removed 4 miles of dikes, right? So letting all the salt water in behind those areas to create an environment that would let those saltwater wetland species do their thing again. So again, right, it's just about different challenges of restoring the hydrology. In a document by the National Research Council, they say that these coastal estuarine wetlands might be our greatest success in at least restoring a wetland that looks like a wetland, right? So you get the vegetation to come back. There's a couple for this. The first is that the natural hydrology is pretty easy to determine. You just kind of have to take out those dikes and let that salt water come in. The other piece of this is that there's a lot fewer native wetland plants in these coastal estuarine wetlands. So, often the species that come in are what a normal wetland would look like. So these are ones that we've had some pretty good success with once we let the ocean water back in. Now, wetlands have an important role to play in climate mitigation. So these authors were looking at the total amount of carbon sequestered annually by different kinds of coastal marine ecosystems. And then they also looked at the potential emissions due to anthropogenic conversion of the wetlands. And so that's a million megatons of CO2 that could be released from there's on the range of tens of millions of megatons of carbon per year, and then a lot that can be converted as well. And so these authors are arguing that from a climate change perspective, we really have to protect these areas because their carbon sinks. And the main reason that their carbon sinks is because respiration occurs a lot more rapidly in dry soil when oxygen is more available. If you remember with the hydric soils, they were dark colored because there's organic matter that hasn't been completely broken down or oxidized. And so what happens when they're saturated is that we have more carbon going into the soil than we have going up into the atmosphere when they're wet. When it's switched though, and there's no longer water there, then you have more carbon being respired and going up into the atmosphere. So essentially, when these areas are wet, they're a net carbon sink. When they become dry, they are now a source of carbon that's being released in the atmosphere. So wetland restoration is a great practice from a carbon sequestration perspective. All right, what about stream and river and wetlands? So You know, the problem with these areas is that there have been so many changes. We talked about the story earlier with dams and other things, that the natural state of these wetlands in our rivers, you almost can't recognize it anymore, right? I mean, just those of y'all that have been to Illinois, right? This idea that you used to be able to canoe from central Illinois to Chicago. I mean, just think about how different that landscape was. So we're going to have a hard time going back to that. So it's recommended that you restore relatively smaller sections, section by section, where you can have good control over the hydrology. You can really manipulate and control that. There's a few examples of this where we are. This is Oklawaha Bog. This is also in the Mud Creek watershed. In the aerial photo on the upper right, you can see Mud Creek kind of going along the edge of this big field, and again, you see those straight line ditches. So there's sections of this that have certainly been channelized, and then a picture of the work that's going on there on the lower left. Again, an agriculture area that's being converted back into its natural state, digging through that riparian zone so the river can back up onto there. And kind of a funny story. One of the reasons that this site is so important. This is in like East Hendersonville area. One of the reasons this site is so important is because of the presence of the mountain sweet pitcher plant, which is an imperiled species. It's federally listed, and this is one of the few places, this bog here, where it occurs. One of the few places anywhere. So scientists were trying to figure out, how to get this plant established and what the habitat was, and they were really kind of agonizing over this and weren't having much luck getting this plant to reestablish in this area. And then they had a piece of heavy machinery that got stuck in the mud and just created a huge depression on this site. And wouldn't you know it, once that big depression filled up with water, that's where the mountain sweet pitcher plant came up. So it kind of shows how sometimes you can get lucky, if again there was a seed bank and everything else was intact, and the right conditions just happened to be created by this big piece of heavy machinery getting stuck in the mud, and next thing you know, the mountain sweet pitcher plant is coming up. All right, so large freshwater wetlands with poor drainage. These are examples of so like the Kissimmee wetlands, the Everglades, those kinds of places. So it was all about draining these for the longest time, right? There are mosquitoes there, alligators, all those things which aren't easy to live with. And people to some extent wanted to farm in these areas, wanted to develop in these areas, but in a lot of cases we've realized that it just doesn't work well, and that the ecosystem services that these wetlands provide are much more important than any kind of development that could happen on them. So the good news, again, since these are such massive wetlands, is that the soil condition is usually usually pretty decent. So if you can just essentially slow up again the movement of water off of these large wetlands, then they can generally do pretty well. So you can do that by filling these drainage ditches like we saw, or by installing water flow control devices, essentially big gates in these wetlands. Then you can do really well. This is one of those flow regulation structures. This is in the Everglades. And so they can regulate just how much water is moving through, and so they can hold water behind this dike if they need to, but then they can also release it as well. So it gives them some management options to keep the wetlands going. The National Research Council thinks that these areas have the greatest potential, partly because there's so much of them, and because since these areas haven't been turned into agriculture or other things, you don't have to worry about reinvigorating the seed bank or bringing in a lot of soil, that kind of thing. So it may be just a question of reconnecting the hydrology. And also remember with this restoration, from a government perspective, if this is private land, they're going to have to think about the cost of acquiring these lands. And so the good news, again, in these large wetland areas is that they're not being used for agricultural development or anything, and so there's not, there's not a premium on purchasing these areas. So because they've been so hard to work with, they've been undeveloped, which has been really a bonus. Okay, so with our paper discussions as well, I think one of the things that we're going to see is that wetland sites in general have not been able to be restored back to the conditions that they were in when they were initially degraded. So this idea of compensatory mitigation, right, where we come in and we restore a certain site to make up for degradation somewhere else in the watershed, it's definitely not a tit for tat sort of situation. It does not equal. So the question then is, should we keep at it? Well, the National Resource Council argues, yeah, we should, just because there's been so much that's lost. Remember, 53% of our wetlands have been lost in the U.S. And so for us to get back some of that ecosystem function, even if we just get back half of the function of these restored wetlands, that's still a major benefit to the landscape. So the plant species that come in, they may not be identical to a reference site, but as we've talked already, the whole idea of a reference site in these times of fast-changing climates and ecosystems is a bit problematic. So if we take that ecosystem function perspective, wetland restoration is still a useful activity and something that is worth investing some time in moving forward.